Okay, this is also similar to the previous example, right? So you're going to apply Laplace on both sides of this differential equation. So when I do the Laplace of 4, that's going to be 4 over s. And then when I do the second derivative, Laplace of second derivative is this much. And when I do the first derivative, 2 times of this much, right? And you're going to factor out Laplace of y, and then you have s squared minus 2s. And these terms doesn't have a Laplace of y, so you're going to put it in the other side, and it's going to look like 4 over s plus s minus 2. I think you're going to combine all that stuff. It's going to be minus 2. And then you're going to divide by this quantity over here on the other side. If you do that, you're going to look like that. And then you're going to do the, and from here to here is your partial fraction, right? So which is I have done it over here. So you just look at that one. So I figure out ABC, and this is your partial fraction. When I take the inverse of the Laplace, you're going to see that's the answer. Okay, I know I go it very fast here, but you can check this one. I've done one more problem here somewhere down here, the very last one. So again, I have this differential equation, second order differential equation with the initial conditions, right? So I apply Laplace on both sides. When I apply Laplace on both sides, the 1 over s plus 1 is this, the guy. And then when I do the second derivative, that's your second derivative of Laplace is that. And then when I do the first derivative of Laplace is that, and then Laplace of y. Okay. Again, you factor out Laplace of y, and then you plug in the value of this initial conditions, and then in the right side it becomes like a s plus 2 over s plus 1, s plus 2 over s plus 1, and you're going to divide by s squared plus s minus 1 or plus 1. This should be plus 1. Okay, divide with that. Now after you divide this one, then we're going to use a partial fraction, which is, what did I do? Partial fraction. You go all the way up here. That's a partial fraction. Fraction decomposition. So I use that, divide by that. So a over this and bs plus c, right? Because this is a quadratic. That's why you got to do that. And you follow that steps. And you're going to see a equal to 1, c equal to 1, and b equal to, where is that? B equal to negative 1 or something like that. B equal to negative 1. You're going to see that. And just plug in there. After you plug in there, and now let's see. After you plug in there, look at that, the term, what you get here. Okay, this is like this part is not a problem, right? After you plug in there. This part is you get that, but when you look at this piece is, you might have to split this one, all right? Because we don't have anything you can use the inverse Laplace of that one. So what I'm going to do is, this is algebra part. So I'm going to rewrite this problem. So that problem's into this completing the square. This one is completing the square. Completing the square. And then after you complete the square, you look like that. And then that's a negative, I want to put in s minus 1, so that's why I put the negative outside. And then if you split, like if you look at on the top, s minus 1 here. So s plus half, I'm going to do it because there's a half here, because this is very close to the e to the power this one. All right, so check this in the table. I want to make it similar like that. So that's why it's going to be half here and minus half. It's just because you add half, that's why I'm subtract half, and then negative 1 is still negative 1. Then I'm going to split the fraction. This guy is going to be over here. That's the first piece. And then what's remaining is like a -3/2. But -3/2, you can break it down into square root of 3 over 2 square root of times square root of 3. All right. Because why I want to do this one? Because that's your other part. You need that one. Because that gives you that sign of e to the power -1/2t, sign of this one when I do the inverse. All right. So check that one. And that's why you get this piece. Okay, so you need to find like a what, how do I split this one? What is the closest one you can do to find the inverse? All right, so this is some work here. Let me know if you have any question here. And that's my final answer for the solution of that differential equation.